Is about cooling tower. So, what comes into your mind when you say cooling tower? May I ask you there?
Alright, when we say cooling tower is an equipment which is utilized to cool hot cooling water in a condenser or any transfer unit by contacting the water into unsaturated air. So there are definitions or terms which must be defined in order for us to know how are we going to calculate the tower characteristics and the different parameters that are very important with regards to cooling towers. So here are the first the terms that we will be using. Number one is the absolute humidity. Absolute humidity is defined to be equal to the pounds of water vapor carried by 1 pound of dry air. Next one, we have the percent absolute humidity or the percentage saturation. So percentage saturation is defined as the ratio of absolute humidity to saturation humidity and is given by this equation. Later on, we will be going to deal with these equations. Next one, we have the percentage relative humidity or RH. This is defined as the partial pressure of water vapor in the air, which is divided by the vapor pressure of water at the given temperature. Slide please. Okay, next term. We have the saturated humidity noted as H sub S. This is expressed by the pounds of vapor carried by one pound of vapor-free gas when the vapor is in equilibrium with the liquid. Next one is the dew point or saturation temperature noted as T sub E. This is the temperature at which a given mixture of water vapor and air is saturated. For example, we have the temperature at which water exerts a vapor pressure equal to the partial pressure of water vapor in a given mixture. So maybe the terms are too vague for you, but later on we will be using those terms. Next, we have humid heat or C sub S. This is the heat capacity of 1 pound of dry air and the moisture it contains. Given by that equation, C sub S is equivalent to 0.24 plus 0.45 H, where 0.24 and 0.45 are the heat capacities of dry air and water vapor, respectively, and both are assumed to be constant. Next, we have humid volume. So there are a lot of terms, so don't be too confused. Alright? So humid volume is the volume in cubic feet of 1 pound of dry air and the water vapor it contains. And saturated volume, V sub S. The humid volume when the air is saturated. Okay. So we also have wet bulb temperature. So I know that in your 153 you are using these terms. So maybe you can still relate. Right? So wet bulb temperature, the dynamic equilibrium temperature attained by a water surface when the rate of heat transfer to the surface by convection equals the rate of mass transfer away from the surface. Next, we have dry volume. Volume in cubic feet occupied by 1 pound of the carrier gas. And enthalpy of the humid gas mixture. The energy of the dry gas and its vapor constituent. So, what is psychrometry and humidification? So, as defined, psychrometry is the systemized knowledge of the properties of air and water, but its broader meaning includes the principles which governs the properties and behavior of mixtures of the so-called fixed gas with condensable vapors. Later on, you will understand how are we going to use the psychrometry. Then, for humidification, it is the evaporation of water into the air for the purpose of increasing the air humidity. And lastly, it involves simultaneous heat and mass transfer. So, as defined, as what I said before, so cooling tower is an equipment used as a tool for cooling the cooling water from a condenser or other transfer units by bringing it in contact with the unsaturated air. So it is also used for conservation of cooling water. There are certain types of cooling water or of cooling tower which industries are using. So we can characterize them by means of fan setting or by airflow direction. With regards to fan setting, we have two. We have the natural draft and mechanical draft. And the mechanical draft is further classified to be induced draft or forced draft. So let's go on to the natural draft. Okay, so natural draft cooling towers. This utilizes buoyancy or density difference via tall chimney. It also uses warm, moist air rises due to the dry, cooler outside air. And at the same pressure, warm, moist air is less dense than the drier air. For the mechanical draft, so we have the induced draft and the forced draft. These are the differences between the two cooling towers. So induced draft, a fan at the discharge pulls air. The fan induces hot, moist air out the discharge, produces low entering and high exiting air velocities, reduces recirculation, and it is also called the draw-through. For the forced draft, so these are the characteristics of the forced draft cooling tower. So fan at the intake pushes air. Fan forces air into the tower. Produces high entering and low exiting air velocities. Susceptible to recirculation. And it is also called blow-through. So, recirculation and the other parameters there will be further discussed in the principles of the cooling towers. Next, so by airflow direction, we have the cross flow and the counter flow. For the cross flow, okay, airflow is directed perpendicular to the water flow. So as you see in the diagram, the airflow here is directed perpendicular to the water flow. Okay? For the cross flow, to see the difference between the two, so counter flow. Airflow is directly opposite the water flow. So this one. This is the airflow and the other one is the water flow. So opposite direction.